So far, we have seen how to load a grid composed of variables by programming its load event. To load each desired line in the grid, we had to give value to the variables and execute the command load. And we saw that we could do it in two ways. Loading those variables with fixed data specified in the code itself. Here we will be loading a single line, but we can load as many as we want, repeating this block of code with the following desired values, and so on. Or we can do it by loading the variables from the data of an entity, using the forh command. We could say that such a grid, composed of variables and without any extra specification, is somewhat blind as to where the information that will be loaded in the form of rows will come from. We will only know that it is being loaded with data from the traction table if we analyze the programming of its load event. Otherwise, we have no way of knowing. In fact, we could perfectly well load some lines from the database grid and others manually. This grid is completely general. It is not specific purpose. The information of each line is loaded in variables and you have to use the load command inside the load event. If you want to load data from an entity, you have to specify a forh explicitly. But we can also have a specialized grid, directly associated to an entity, and so you will already know that you will have to load your data from there. It's like having a forh automatically associated with the grid. That's what we'll introduce in this video. We call it a grid with a base table. So the first one is usually referred to as a grid without a base table. What if we could indicate to the grid that it will have as base transaction traction, and instead of specifying variables for the grid columns, we choose directly the attributes attraction ID, attraction name, country name, and attraction photo. And in the load event, we do not program anything at all? Won't this be enough for GeneXus to understand what to do? The answer is yes. Let's try it in another web panel, Attractions Info 2. We drag a grid to the web layout again. In the dialog box, instead of variables, we choose attributes. Let's filter by those of the attraction entity, so we choose them more easily. Hold down the Control key to select the ones we click on. Let's move the photo to the right. And how do we indicate to the grid that the base transaction will be attraction? If we edit the properties of the grid, among them we see the one called base TARN. There we write attraction. It is the same as the base transaction of the forh. We don't need to do anything else. Let's execute. We see that all the attractions that we have entered in the database appear, ordered by attraction ID, the primary key. The same as when we have a forh, from the value of the base TRN property. As GeneXus knows the data model, it will determine that the table to traverse will be attraction, since it is the table associated to the attraction transaction. The grid includes the attributes attraction ID, attraction name, attraction photo, and country name. The first three belong to the base table of the grid, which is the table that will be traversed record by record, while the last one belongs to one of its extended tables, which is accessed to retrieve the country name. Note that the navigation logic is identical to that of forh. Here is a comparison of the two alternatives, that of the generic grid without base table, and the grid with a base table. We can see that the second alternative is much simpler. It has an implicit forh that even has a built-in load command to load each line of the grid. It is not even necessary to make it explicit. Something we have not said is that it is not mandatory to specify the entity associated to the navigation. If we were to remove the base transaction attraction from the forh, which is equivalent to removing the base RN property from the grid, both web panels would still behave the same. GeneXus is able to infer with the committed attributes which base table is indicated. For a beginner level, we recommend specifying base transaction to have under control what we want to browse. We can corroborate the equivalence between both web panels by comparing the navigation lists. Here we have the one of the web panel with generic grid and load event programmed explicitly with for each. And here we have the web panel with specific grid, with attributes and base transaction. We can see that this one shows exactly the same navigation inside the load event. What does not appear explicitly is the line that says for each attraction, because in this case it is implicit. Since a grid with attributes is equivalent to a for each, we may wonder how we do to sort or filter the retrieved data, since we do not have access to the programming of the for each because it is implicit. As we have the base Rn property of the grid to specify its base transaction, we will have the order and conditions properties, the multiple where clauses that could be specified in the for each. Here can be written as a semicolon separated list. Let's look at the examples we tried earlier when we used the for each to load the grid without a base table. If we want to order the attractions alphabetically, in the order property we include the attraction name attribute. Let's execute. The navigation list shows us that the attraction table will be traversed, now sorted by attraction name. For what it will use the unique index that we had, the same as it was seen when we programmed the for each in manual form. The table will be traversed from the first record to the last one. And for each record in the attraction table, we will access the country table to obtain the value of the country name attribute present in the grid. As we did before, we could sort first by country name, and then by descending attraction name, using both attributes in the order property of the grid. If we ask to execute and go to the navigation list, we see this order reflected in the report, and the same warning that we saw before regarding the non-existence of an index by these attributes. In execution, we see exactly what we want. We can filter the records as we did before in the for each, and for that we have the conditions property of the grid. We can directly write there the filter condition, which would be the where of the for each, or open the code editor to write more comfortably. We want to filter the attractions whose country name has the value France. We must culminate the condition with semicolon. Here we use a declarative syntax, in a similar way as we did in the rules and formulas. Let's execute. If we go to the navigation list, now it indicates that the entire table is not traversed, but only those records that meet the filter condition, all identical to the case of for each. We see that the filter works as expected. As this is a web panel, it would be desirable that the user can choose by which country he/she wants to filter. To do this, we will need to insert a variable in the web layout above the grid. In the selector, we choose New Variable and call it country name as the same as the attribute. We see that it is already based on it. And now that it is created, we choose it in the selector. The user will write a name there. We are missing to indicate to the grid that it should filter the attraction records according to that country name. So we edit the grid properties and change the fixed value we specified in conditions to the variable and country name. Let's execute. In the navigation list, we see how the variable now appears in the filters. And if we go to the object in the browser, first we face the empty grid. Why? Because the value of the variable and country name is empty, and when we wanted to load the grid with the attractions with empty and country name, it did not find any. On the other hand, if we type France, we see how the attractions of France are automatically loaded, And if we now type China, we see that of China. If we want that when the user leaves the filter field empty, then the filter is not applied. It is very simple to achieve. The condition is conditioned. Let's edit the code of the grid condition. It will be enough to indicate that this condition is applied only when the variable is not empty. Let's start the execution. In the navigation list, we can see the condition by Vern on the condition. And in execution, now when the field is empty, we can see that nothing is filtered. The 3 attractions that we had appear. But if we type Fran and we stop, we see that the grid is empty. And if we completed instead France, there appear the 2 attractions of France. We can already observe that every time the user modifies something of the value of the variable, which is working as a condition of the data to be loaded into the grid is refreshed. That is, it is attentive to what happens with that variable so as to be always updated. Of course, with this option, the user must type exactly the name of the desired country. Another alternative would be that instead of any editable field, the variable is transformed into a dynamic combo. To do this, positioned on the control in the layout, we modify its control type property, changing it from Edit to Dynamic Combo Box. That the combo is dynamic means that it will take from some source the data that will be offered to the user to choose one. By default, the source is the database, and that is why the value attributes appears for this property. The values will be taken from country name because this variable was based on that attribute. So you already figured that out. What about the descriptions, which are what the user will see? In this case, too, it will show the same thing that will be stored in the variable. But it doesn't have to be that way. The variable could store the ideas of country, and we could have possibly called it country ID, and show as description the country name. Of course, in that case, in the grid, we would have written the condition like that. What we would have to add to the variable control is that it also presents an empty item in the running combo. So when that is the value chosen by the user, it is not filtered. Let's execute. Let's see that the navigation list shows the navigation to be performed on the database to fill the variable country name. Now we see the option, none of the combo that makes that, there is no filter. And if we deploy the combo, we see the names of the countries that we have at the moment in the database. If we choose France, we see the corresponding attractions. We saw then that the conditions allow to be conditioned, and this is true in all the places that implement navigations. Yes, both in the conditions property of the grid, as well as in the where clauses of the FORIASH. We have seen that a grid control with attributes silently determines a navigation identical to that of a for each, and that, therefore, we usually name it as a grid with base table. Moreover, it performs an automatic loading of the result without having to program anything. The attributes correspond to information from the database that you want to display, sort, filter, so GNexus understands that it must go to look for that information, just as it does with a for each, going through a base table and accessing the required data from the extended table, and also that it should display them as grid rows. The base TRN property, like the FORIC, allows us to specify the level of the transaction whose data we need. We call that table the base table of the grid. All the attributes of the grid must belong, as in the case of a for each, to the extended table of that base table. Just as in a for each, we sort the information with the order clause and filter the data to be returned by the query with one or more where clauses. To do the same with the grid, we use the order and conditions properties respectively. About the end of the video on the FORIACH command, we advance that its navigation logic will be identical to what we will find in other forms. We have just seen one of them, that of the grid with a base table.